Okay. So, the distance formula. This is another way that you can do this distance calculation stuff. There's actually two methods. And I'm going to do an example with you guys, and I'll do both methods so you can choose which way you want to do it. It doesn't matter to me. I happen to like doing it the Pythagorean theorem way, but you can use this equation as well. All right, and this equation comes directly from the Pythagorean theorem. I could do a proof for you and show you and all that and everything, but we don't really have time for that. So I'm just going to write down the formula for you, but then I'll show you, like I said, both ways of doing it. So the distance formula looks like this, and you've probably seen this before. It's a big giant square root, and it's x2 minus x1 squared plus y2 minus y1 squared. The advantage of the distance formula is you don't have to draw anything. All you need to know is the numbers and you plug them in. The downside of the distance formula is I'm not going to give this to you. I'm going to expect you to know it if you're going to use it. So you'd have to memorize it. Now some people memorization and they're like, they seize up and they don't want to do it. Some of you might look at that and say, oh, I can kind of see the pattern in there. I could memorize that. That's not a big deal. So it's just up to you. Okay? So let's try an example. Oh, do you still need more time? I'm sorry. There are minus signs inside the square or inside the parentheses, and it's a plus sign in the middle. Okay, so it's x minus x squared plus y minus y squared. So yeah, this is a plus sign. It pretty much is the same thing. It's just written as a formula. Yeah, this is a subscript. This is a 2, this is a 1, this is a 2, this is a 1. And then they're each outside the parentheses are squared. All right. Are we okay to move on? Okay. All right, so we're going to find the length of a segment AB, and I'm going to give you coordinates for A and coordinates for B. So A, come on, pencil. So A is going to be 2, negative 5, and B, 7, 2. All right, so the first method, we'll do the formula. All right, I know you guys probably don't want to do this if you use the formula, but the first thing that I would do with this, just so you don't make any mistakes, is to actually write the formula out without any numbers in it. I always do that whenever I use a formula for anything, because that way, if something does happen where I've made a mistake, I can go back and I can see where I made my mistake. So it's x2 minus x1 squared plus y2 minus y1 squared. So I've got that down first. And just double check that that's right, and it is. Okay, now I can start putting numbers in. So that's going to be the square root of x2 minus x1. Well, find the two x's. x2 usually refers to the second x, so that would be this one. And x1 is the first x, that would be this one. So 7 minus 2 is what we're going to have right here then. So parentheses, 7 minus 2 squared. And then we got to subtract our y. So y2 minus y1. y2, 2. y1, negative 5. So 2 minus negative 5. And then that's going to be squared eventually. All right, so doing order of operations, I got to do my subtractions first. What's 7 minus 2? 5. Okay, thank you. So 5 squared. And then what's 2 minus negative 5? That would be 7, right? 2 minus a negative is 2 plus, so it's 2 plus 5 is 7. Okay, and then we got to do the squares now. What's 5 squared? What's 7 squared?
25 and 49.
25 plus 49, yep. And 25 plus 49? 74, good, yep. Okay, so the distance is the square root of 74. Now, unlike the other ones that we did, this isn't coming out to a nice, neat number, right? But you can leave it that way, exactly. Or if you like decimals, there are people that enjoy decimals more than leaving it as a square root. I'm totally fine with that, too. It ends up being about 8.6, I believe, if I remember correctly from third hour. Yeah, 8.6. Okay, so that's using the formula. Okay, it's very algebra heavy. Okay, you got order of operations and all that too, and you got to remember the formula, and it takes a little bit. Method 2, this is the one I like to use because I'm kind of a visual person. I like to see it. So this is using a graph and the Pythagorean theorem. If you have a hard time drawing a nice, pretty graph, this might not be the one for you. So, because the first thing you need to do to be able to apply the Pythagorean theorem is to plot the points. So, A is at 2, negative 5. So, 2, 1, 2, 3, 4, 5, negative 5. And then 7, 2, so 1, 2, 3, 4, 5, 6, 7. And then up to 2, 1, 2. So 7, 2. Okay, so here's our segment we want to find the length of. And this was, let's see, this is A, this is B. So we're going to do like we did before. We're going to make a triangle out of it. And then we just got to figure out how far these two segments are on the bottom and on the side. So we can count it again, as long as we've been consistent with the little tick marks, okay, and careful with that. So over, how far did we go? 5. Okay, so it's 5 over. And how far up and down? 7. Okay. So if I'm going to do the Pythagorean theorem, I've got A is 5, B is 7. So 5 squared plus 7 squared equals C squared. Okay? The actual calculation part of this one's a little bit easier. Okay? Because we don't have to do all that subtraction and big square roots and all that. So 25 plus 49 equals C squared. And again, what is 25 plus 49? 74. If 74 equals C squared, I got to square root both sides of that. So C is equal to square root of 74, which is the same answer we got up there, right? And if you like your decimals, 8.6. So, like I told third hour, pick your poison. Which one do you like better? Or which one do you hate the least? I don't know, whatever. So, but that's how you got to do it. One of the two. All right? So.